Hello and welcome to this lesson video where we will learn about how to design balanced cut-to-fill operations by optimizing the use of different earthwork equipment. This video covers the shown two learning objectives. There are three main types of earthwork equipment that can be used in cut-to-fill C2 CTF operations: trucks, scrapers, and dozers. To best explain their differences, let's watch some videos. Here you can see a dump truck being loaded by a loader in the cut area. The truck is an off-road truck because it's large and cannot drive on our regular roads and highways within the standard lane width. You can see other equipment pieces also working, like these two dozers. The truck finished loading and now is heading to the fill area. The truck arrived at the fill area and will start dumping its load. Afterwards, it will go back to the cut area. Here's another video to see scrapers in action. As you can see, it's guaranteed to see a water truck spraying water to reduce the dust and also to make it easier for the equipment to drive on the soil. Here you will see a scraper coming and just scooping the soil in its belly. You'll see also another scraper doing the same. This happens in the cut area, and the scrapers take their loads to the fill area. The scraper arrives at the fill area and lowers its billy and open it to drop soil. Pay attention to the soil, how it goes out of the billy below the scraper. Unlike the trucks, scrapers dump their loads in layers of soil, not piles. After the scraper finishes the load dumping, it turns around and exits the fill area to return to the cut area. Here's final video embedded in our presentation video. Here you can see a D11T Caterpillar dozer with rippers in the back, pushing the soil from one cut spot to a fill spot nearby. It's that simple. The dozer cuts the soil top layer accumulated in front of the big blade, push it to the fill spot, and then returns back to the cut spot. So after watching the three videos, we can conclude that every equipment is designed to perform a specific cut-to-fill operation. At least two equipment types are needed in trucks, and loaders or excavators. Scrapers can operate by themselves, but they can also assist each other or have assistance from a dozer to have a little push when scooping and loading the soil. Finally, dozers can work by themselves. We'll learn about each of these equipment type in detail in the future. Also, we saw in the videos that trucks can operate for longer hauls. Scrapers are better for medium hauls, while dozers are for short cut-to-fill earthwork. We call these optimal haul distances for the different heavy equipment economical haul distances. Every equipment type has a range of economical haul distance where it achieves the optimal production rate and minimal cost per unit moved. This table shows the economical haul distances for dozers, scrapers, and trucks, which comply with the video observations. For very short hauls, dozers are the best equipment to use for balance zones of up to 300 feet wide. For longer distances, up to 5,000 feet, scrapers are the recommended equipment. Finally, trucks are the most mobile equipment for hauling due to their original design advantage. Imagine from the dozer video, if we use the dozer to push the soil for the same distance traveled by the trucks, we would have waited for every truck to deliver just a blade load. On the other hand, it does not make sense to load the truck by a loader, so it can move the soil for just 300 feet distance, which is about 4/5 of a football field. We can use the economical hold distance then to design an efficient cut-to-fill operation by identifying from the mass diagram the cut-to-fill zone for each equipment type. We can do that by fixing a balance line for each equipment to its economical hold distance and trying to find its place on the mass diagram that intersects with the diagrams at the ends of that line. For the shown mass diagram, we need to identify the zones where the scrapers and dozers will work. We set two balance lines equal to the scraper and dozer economical hold distance. Then we find the zone where the dozer's balance line will snug within the mass diagram. The dozer zone is now identified with its whole quantity and the average whole distance, which we will cover in the second part of this lesson. We can do the same for drawing the balance line of the scraper to visualize its cut-to-fill zone. Here is another example to visualize the cut-to-fill zones and their physical holes. Here you can see how to use the economical hole distances to identify the dozer and scraper cut-to-fill zones, like we did in the last slide. Then we can identify the total quantity or yardage for each equipment and the boundaries of cut-to-fill zone. We can notice that the scrapers pass by the work zone of the dozers, so it's critical to have a close coordination between their CTF operations to make sure whole routes of the scrapers are not blocked or not excavated or filled at acceptable rate by the dozers. I hope you enjoyed this video about different equipment used in CTF operations and how their economical hold distance can be used to identify their work zones. In the second part of this lesson, we'll learn about how to calculate the whole average distance and the grade for each CTF operation and zone. Take care.